Hi guys, today we're going to learn about a perpendicular bisector. We're going to learn how to construct a perpendicular bisector using GeoGebra, which is a web-based program. And then we're also going to understand and apply the perpendicular bisector theorem. Now, if we were face to face, if you walked into my classroom one day, at the door, I would hand each of you a magnet. It's a circular magnet, different colors. And in the back of my classroom, I have a chalkboard. And I would draw a straight line and I'd label the endpoints A and B. And I'd make people a little bit nervous because I would tell them, I'm going to give you a task. And that task is you have to put your magnet anywhere on the chalkboard that's going to be the same distance from A that it is from B. Now, the first person gets picked out of the hat. They're delighted because they know they can just come over here and they can just pop this down somewhere in the area. We're just kind of guesstimating, right? So they put their magnet down, feel very proud of themselves. But it's the second and third person that are kind of a little bit nervous. And, the second person walks around and they kind of stare at the screen. And then they kind of try to do this, where they put their magnet as close as possible to the other magnet. So they kind of look like something like that. And then the third person would go and kind of think about it a little bit. And then they too would do something like that. And now by this time, the fourth person knows they can put their magnet here. And the fifth person knows. And then everybody just kind of gets out of their seat. They stop waiting for me to even call their name, which is one of the few times I don't mind a process in the classroom not being followed. But there you go. They have everything in a straight line. And then I would come with my ruler and I would draw that line again. I'm doing my best I can with this aim right here. Okay. Well, you might notice something about this line, and there are going to be three things that we're going to be able to notice about this line. This is what we call a perpendicular bisector. First, all the items are in a straight line and they form a right angle. So that's where the word perpendicular comes from. Okay. The second thing that happens is it cut this line in half. So we could put a little line right here. And if we labeled this point, this little pink point right here, I'm going to label it M. AM and MB are the same length. So they are AM equals MB, or AM is congruent to MB because it's the same shape and the same size. Okay. And then there's a third thing that we also know. What did I tell you? What were the directions? I told you, put your magnet so it is the same distance to A that it is to B. And I'm going to use double stripes here so that it doesn't get confused with the single stripes of the ones down below. So let's label this point C. AC is equal to CB. Now, the reason I use double stripes and not a single stripe is because I said the single stripe is the length of MB and a single stripe is the length of AM, and they are equal to each other. But we don't know if M to B is the same as C to B, so we don't want to use the same symbol. Okay. Though we have this other person that put this green marker there. We don't know what its length is, but we know whatever this green magnet to here is also the same to here. And so I'm going to use a triple stripe on that one. So those are the three things about perpendicular bisectors. Number one, it's a segment or a line that cuts another segment into two equal parts. Okay. Number two, it forms a right angle. And we could see that there was really just four right angles. So because it's on a straight line and you did this, so if this is 90, then this is 90, then this is 90, then this is 90, right? And the third thing is any point that is on the perpendicular bisector is the same distance to each endpoint of the segment that it bisected. That's what I asked you to do with your magnet. I said, put this in a place so that it's equal to this side and equal to this side. That's true of any point you pick. It'll be same distance to the left as it is to the right. Okay. Now, after we did that activity, we would do something very exciting, which is get our compass out for the first time. So some of you may have bought a compass. We also have a class set of compasses, but we would learn how to use our compass to do that same activity. So the first thing that I would be asking you to do is I would be asking you guys to draw yourself a line segment on your paper. So that's what you would do. And I would also ask you to please kindly label the 2 points on the end. So we have a point A at the end right over here and a point B at the end. And we would label them A and B. Okay, now we are going to try to do what's called construct a perpendicular bisector. So I would take my compass and put the silver point on point A, and I would widen my compass so it's more than midway past the line segment. So I don't want to put my red pencil here. I'm going to put it over, like if the midpoint's here, I'm going to move it. Okay, and then I'm going to take it and I'm going to make a little swish like this. I made it very dramatic, but you don't have to make it that dramatic. I'm going to do the exact same thing from letter B. And when I mean the exact same thing, I'm going to not change the spacing between the silver and the pencil. So I'm going to do the exact same thing and make a switch. Some teachers call this the fish. Some people call this the football. You can call it whatever you want, but that is the distinction of doing a perpendicular bisector construction. Because now what you're going to do is you're going to come over and you're going to put a point right here at letter C, and a point here, which we're going to call letter D. So I have C and D. So I make my swish, swish, my fish, the football, whatever you want to call it. And then I'm going to come over here and I am going to draw a straight line that connects C and D. Okay. And that right there is what I call my perpendicular bisector. And then we would have to mark this up. So what was the first thing we learned? Let me go back real quick to this top problem. The first thing we learned was that the perpendicular bisector cuts a segment into two equal parts. The second thing we learned was that they create 90-degree angles. And the third thing I learned is that every point that's on the perpendicular bisector is the same to both endpoints. So when we come over here, we label that center point M. We say, okay, we'll cut this line in half. So AM and MB are equal lengths. Okay, we know that there were 4 right angles that were being created. So we make little right angles here. Okay, and then the next thing we knew is that when we do our problem, that the length from C to A is the same as the length from C to B, and the length from A to D is the same as the length from A to B. Now, that is my perpendicular bisector. So if I have a perpendicular bisector, I know 3 things. It got cut in half. This segment here got cut in half. They form 90-degree angles, and any point on from letter A to the perpendicular bisector is the same as that length from the same point to letter B. So I'm going to mark this up. Now, because you did the swish with the same length, we know that A and D and B are the same distance as AC and CB. Because of that, swish was used with the same compass length. But that is what we would have done in the classroom. Now, we're not in the classroom, so we are going to launch our web page, and we are going to go to a site called GeoGebra. So I'm going to go here and type GeoGebra.org. So geo from geometry and gebra from algebra, forming GeoGebra.org. The next thing you're going to do is you're going to hit Start Calculator. The next thing I'm going to have you do is come over here. There's 3 icons, a calculator. Next to it is a circle and a triangle. We're going to click that, which is our tools menu. And just so we're all kind of looking at the same thing, we're going to scroll down and hit this more button right here so we see all our options. So that's the first thing. So this button here, and then scroll down and hit more so you see everything. Okay, we're going to also clear up this screen right here. So I'm going to go to the right-hand side where these gear is, and I'm going to uncheck Show Axis. I'm also going to hit that gear and uncheck Show Grid and pick No Grid. So I have a blank page. Okay, this is so much easier than it is with a compass using GeoGebra. The first thing we're going to do is we're going to slide down here, and we are going to pick this point. See where it says point? And I'm just going to click 2 points on my paper. And I'm going to click where it says line. I'm going to click segment, where it says segment right here. And I'm just going to click on those 2 points again to get my beautiful segment. If you had just done segment, it would have given you the 2 points anyway. I just like to give you the opportunity to create points as well. Okay, now here's how much easier this is on GeoGebra. Right here where it says construct or construct constructions, you remember the outcome is you can do a construction. I can construct. You're going to pick the perpendicular bisector. And watch the instruction that pops up at the screen. It says perpendicular bisector. Select 2 points or one segment. All right, well, here's my one segment. So I'm just going to click on it. Ta-da! It created my perpendicular bisector. And I'm not going to go ahead and locate that. I just want to make sure that you did it. I'm going to have you go back to where it says point. Okay. I want you to put a point at the top of the perpendicular bisector and a point at the bottom of the perpendicular bisector. That's the second thing. I want to label this point right here, which we can do by hitting this button that says intersect. See this button over here that says intersect? And then I'll just pick these 2 points, 2 lines. So it gives me the intersection point. Okay. And the last thing I'm going to have you do, or the second to last thing I'm going to have you do, is create the 90-degree angle on your paper. So you're going to go to where it says measure, and you're going to pick angle. And you have to do it in the following order. I'm going to create the angle that's here. So we're going to click C, I'm going to click E, and I'm going to click A, and there it gives me my right angle. So there's my perpendicular bisector. We have 2 more steps to do. The first thing we're going to do is we're going to go over here down, oopsie daisy, I went past it. We're going to go where it says media, and I'm going to hit text. And what you're going to do is you're going to write over here, you're going to write Miss Kulkarni's, you're going to write your name. So write your name, perpendicular bisector. If you want to abbreviate that, you can write perp bis. But you're going to write your name and then perpendicular bisector and put that next to your perpendicular bisector. And then you're going to take a screenshot. Now, if you have a Chromebook, the best way to do a screenshot is to hit this control key right here and do this little button right here. It looks like a rectangle with 2 lines next to it. If you want to be able to select what you're going to screenshot, you can hit control and the shift key at the same time, and then also hit those buttons at the top. So you would hit 3 buttons at the top. I myself have a Dell laptop that was given to me by the school system. So I would hit FN print screen, but I'm also going to use this snipping tool that I have on my website. So I'm going to do a little snip here where I just choose what I want. So I want this little perpendicular bisector. It copies it into what's called the clipboard. And then I'm going to go to my Google Drive, to this assignment, and I'm going to paste it. And that's all I have to do to turn this in as a classwork grade. So again, just to repeat, a perpendicular bisector, that's what our outcome of the day was supposed to do, is a line which cuts a segment into 2 equal parts. It creates a 90-degree angle between the segments, and every point that is on the perpendicular bisector is the same distance to A as it is to B. So I hope you kind of understand that a little bit. That is, of course, our outcome. Have a great day.